we are here to discuss that how we will be approaching various DILR sets and solving them, and also be looking at we'll also be looking at key how to judge what is an easy set and which is a difficult set, how to take a call on that. So let us first understand. So we're trying to what we're going to do is we're looking at various approaches or how to approach a DILR set, right? And in that thing we're also looking at having a framework or a metric to judge its difficulty level, whether we should be doing this set or not. Should this set be attempted or not? Whether to attempt or not to attempt. So that call also we'll be taking today. So so basically, before I jump into this, I just would like to introduce and put some idea into the mind of the learner that what exactly is a DILR set. So I believe that DILR set is nothing but a set which is based on information theory, like any quant question is. The only thing is this might involve many more variables than a regular quant question would. So when I say that it has many more variables, we're talking about large number of variables. We might know values of all these variables. So we might be in a situation where we know the values of all these variables and we just need to calculate other variables or other values based on these variables, or we may know value of some of these variables, and maybe in an extreme scenario none of these variables. So when you know the value of all of these variables, you would obviously you'll understand that you need to use these variables to find other values, other variables. I will give you examples for these as I go on. So basically this is just nothing but calculation based or applied calculations to find other things. When you talk about some variables you know and some you do not know, which is same as none you know, then now what is going to happen? You would require certain conditions or clues to resolve the values of these variables. And when you resolve the value of these variables, then you would go forward to do the further calculations to find answers. So primarily, if you look at it, one thing becomes very simple right now. If you already know the values of all the variables and you just need to do calculations, this sounds to be much more simpler than a scenario where you have to resolve the values of some variables and then do the calculation to find the other values and everything. So what are these variables that we're talking about? What are the clues that we're talking about? So I'll give you a brief introduction about these things before I go about solving these questions in any form or the other. Right, so let's focus what do I mean by these variables. So let's talk about variables. So when I talk about variables, I talk about something called the variable space. Okay, so what is the variable? So in variable space, we would have primarily two types of things. One would be the primary variables. The other would be derived quantities, values or variables. Now it's not always very apparent which one is primary and which is derived. Okay, sometimes they are interchangeable, that is also fair. But let's have a look at this scenario, that when I say that I'm talking about primary variables, what do I exactly mean? Primary variables in my mind are the very basic or rudimentary variables that are a part of the question. Now let me give you an example. Let us say we are going to work on the DI set where we're talking about some companies, and let us say we have some companies like 5 companies, and we would be looking at their, let's say, the 5 companies products, and we will be looking at the products, the cost price of the product, let's say the selling price of the product, and then from there might be looking at number of units produced or sold, yeah, and we are looking at what profit a company makes and what profit percentage is there. Now this seems to be a very simple scenario. Now to solve this, and it could be also be total profit is. So profit per unit, and this is, let's say, total profit. Now in this scenario, let's say we will be given some graphs or charts or data in form of a table over, let's say, a couple of years for this. Now the first thing that might come to my mind is that in my mind, if I know the cost price per unit is given, selling price per unit is given, and number of units are given. These are three quantities that are given. From here I can calculate profit percent, I can calculate profit per unit, and I can calculate the total profit in that year if I know the total units also. Yeah. Now, so some of these things, so I might say that these are my basic variables. So this is my basic variable 1, my basic variable 2, and my basic variable 3. These are my 3 variables based on which I will be able to solve it. It is possible that I have not given these 3 basic units. It is possible. Instead of that, let's say I am given profit per unit and I am not given selling price per unit. Now, is this a derived quantity? Is this a derived variable? Or can this be a basic variable, and if I know this, can I get this? Yes, I can get that. So basically the relationship here is a unique relationship which is totally reversible, which means if I know CP per unit and I know profit per unit, it is as good as knowing I know the SP per unit, then I need not do that, and that is where the definition of a basic and a derived unit slightly changes. But in my mind, the way I have been structured to think, I always like to think of profit being derived from SP minus CP rather than SP being derived from CP plus profit. Right? So I might like to consider this as a basic unit that doesn't lose the generality. So it's not given, but if I'm given the profit per unit, then I can obviously use and turn it around and all these things I can do. So in this case, the derived unit and the basic unit are reversible or interchangeable, because you know one, it will lead you to the other. This is the scenario that is possible. Plus, other than this, there are some other scenarios where this might not be possible. For example, let me just take another example. Let's talk about scores of students, or marks that a student scores. So marks scored by, let's say again, 5 students in a test, and also their ranks or position that they get in the test. So there were 5 people who were taking this test, right? Now let's look at this. So I have, let's say, students are A, B, C, D, and E. I'm given some conditional scores that is a test of, let's say, it's a 20 question test, let's say, and the scores go from 0 to 20. Let us say that. Let's say the scores go from 0 to 20, right? So if I know the 20 scores, so if I know the scores of the 5 students, if I know the scores of the 5 students, I would be able to derive the rank of the 5 students. Yeah, I will be able to derive the rank of the 5 students. But look at it from the other point of view. If I know the rank of the 5 students, I say A came second, B came first, C came third, D came fifth, and E came fourth. So these are the positions of the ranks. Yeah, first, second, third, fifth, and fourth. Yeah. So from this data, I will not be able to actually pinpoint the scores of the students. So this is not reversible. So my target in this scenario is again based on the question, right? My target in this scenario is that my basic variable or my primary variable would be the scores, depends on the question. If the question is actually talking about scores, and my derived would be ranks, right? So this should be one criteria. But elementally, always speaking, will scores always be the derived value, the basic value? Not necessarily. Suppose there is a question now which talks about, okay, it's a 20 question thing, but let us say it's an MCQ test. Okay, and in MCQ test, we say anybody who gets a question is plus 3 and minus 1. Right? Just like cats, you get a right, you get a plus 3, you do a wrong, you get a minus 1, you don't attempt it, you left at 0. Now if I know the scores, I may not know how many rights the student has got and how many wrongs the student has got. Yeah, if I and how many he has left. So if I know the score, do I know how many rights he's got? No, I do not. So if somebody, let's say in a plus 3, this kind of a scenario, let's say a person has scored something like, let's say 15 marks, then he might have got 5 right and 0 wrong, and he might have left the others unattempted. It is also possible that he might have got something like 6 right and 3 wrongs, right? And might have left the others unattempted. So if I know this and I make this my basic score or my primary variable, then these are lost out. It's because it's irreversible. So in this scenario, if my questions involve the fact of finding out how many right they have done, how many questions they have attempted, and things like that, I would like to make my primary variables as the questions attempted correctly, incorrectly, and left by the student. And that is what I would like to do and do this. So this is something that you do with primary variables. Along with this, so what we are seeing now in this scenario is, before I finish the variable thing, is that you have variables, yeah, and then you have some other variables which we call derived, and then you have, connecting these, you have some transformative functions. Yeah. So by what do I mean by transformative functions? I mean formulae that are given, that how do you go from one kind of a variable to the other variable. Sometimes these functions are reversible, so that you can interchange and you can go back. Now transformative functions can be of various forms, right? And they lead to different kinds of conditions. So you could have transformative functions which are like piecewise functions. Now, what is a piecewise function? So you could have transformative functions which are piecewise functions, which I will talk about in clues also when we get there. But by piecewise function, I mean I could say that if you're traveling in an auto, let us say, okay. So and in that auto we can say if you travel from 0 to 5, the per kilometer rate is 15 rupees per kilometer. But the minute you make it up to 5, right? You make it greater than 5, but up to 10, I can say this becomes 14 per kilometer, and so on and so forth. So you get different values at different rates, and then you try to figure out this. This could be true for discounts also. So if you buy some up to 5 items, you get no discount. From 5 to 6 items, you get so much discount. From 5 to 10 items. So these are piecewise functions, and these are the transformative functions. Sometimes these functions could also be ranking and order functions. By what do I mean by ranking and ordering functions? These could be functions which are talking about how you have scored here will derive, like we spoke of, position of a student, right? So we can say a student, there were 5 students who took a test. If they scored more than 75%, yeah, so they would be called scholars, yeah. And if they are get a rank 1, they'll get a prize. So a rank 1, if that rank 1 is a scholar, he might get 10,000 rupees as prize. If rank 1 is not a scholar, that means everybody scored less than 75%, they get 8,000 rupees prize. So again, a piecewise function and a ranking function is a transformative function trying to get into derived variables and derived states. Yeah. So when you work on these scenarios, so what I want to say is, what we need to keep in our mind is that there are going to be variables which we need to capture initially, which we'll learn to find within the first few under a minute in a question, and we'll be able to know, okay, how they are related to each other. That's the only thing that we need to do. So we can now, so I've given you some examples of the variables. Now let's talk about how do we, if we get into a scenario. So I spoke about 2 scenarios earlier. One scenario was, I know all the variables are given. I need to do the derived, run the transform it, get into derived values or variables. Yeah. So now all the variables I meant, so this could be, you are given the basic ones, which you consider to be basic, or you given some derived ones, but you can transfer them back to this. So that's up to you. So this will be this kind of a scenario, right? Then the complexity of this question depends on what kind of functions are given to do this, but they're all calculation oriented. might take some time, but the cognitive load will not be very, very high. The other is we need to figure out some variables, some or all. They are not given. When you need to figure out those variables, you will need some clues and conditions. So what are, so you don't know this, you need some clues or conditions. Clues, constraints or conditions. Now let's look at this. When you try to figure out those variables and you need to determine how many you don't know, first of all you need to determine out of the total variables which are given, how many do you know for sure? If you want, so the first thing that you now look for are definitive situations, definitive direct values. By direct values, I mean it is given in a question, like in an arrangement of 15 people in a linear arrangement or on a table or whatever. You told that A sits in the middle, so you know his position directly, right? Or you're given the cost price of this product is 10,000 rupees. You're given that value directly. That direct value can be given to you in multiple forms. It can be given to you in form of a table, a chart, prose, in the data set, in terms of written inside this, in terms of clues 1, 2, 3, 4, or a line graph, bar graph, by pie chart. So you are given those. Next is, so once you've done that, so let's say you started a question and you said, oh, I have understood the variables, and the variables that I need to solve this question, the very elementary variables are, let's say, 15. You go through your clues and you find out of those 15, I have been given 10 values directly. So how many are still left unresolved? Yes, you're right. There are 5 were left unresolved. Now, if you, so I would like you to talk. I like to talk about a term called degree of freedom. So before I'll come back to this, uh, yeah. So I like to talk about a term called degree of freedom, and then maybe discuss this in an algebraic situation. Now, I would also encourage you to read. If you want to know more, you can always come and talk to me personally, and I will be able to help you. But it's a good idea if you read something called degree of freedom. It is taught at school in elementary level, yeah, and basically it only says one thing. It says that if you have 10 variables, you need 10 equations to find their exact value. If the number of equations are less, then you will have some variables which you will not be able to pin or resolve to an exact value, and those number of variables would be equal to number of variables minus the number of equations. So number of variables minus the number of independent equations that are given to you. So this will be your degree of freedom in a very simple form, right? So it means, so when you talk about out of 15, I have been given, I know 10 values directly, I'm left with 5. So currently my degree of freedom is 5. That means there would be 5 variables whose value if I pin, I'll be able to find the values for everything else, right? So I don't know 5 variables, there's nothing. Now how do I find these values out? There will be again some situation in which I would be given some more equations. When I say equations, the operator in that would be equal to. So it is possible I am given a situation which says that sum of the remaining variables v1 plus v2, some total is given, is equal to 100. So that's an algebraic equation that's given to me. There is also going to be another equation which might say twice of V1 is equal to V2, which means V2 is twice of V1. That could be given. Or you might be given the form of a ratio. You given form of a ratio saying V1 is to V2 is to V3 is in the form of, in the ratio of 1 is to 2 is to 3. This would also resolve into two equations, and the two equations would be V1 twice of V1 is equal to V2. This is one equation, and the other could be thrice of V1 is equal to V3. Remember, the equation between V2 and V3, if I were to write this equation and I were to say that twice of V3 is equal to 3 of V2, this is not an independent equation. It can be easily derived from these two. So there are only two equations in this. So data of this kind would be given, and these equations are also algebraic in nature, and they have an equality form. I can use the concept of simultaneous equations to solve and find this value. The minute I do this, this question becomes very algebraic, and I say, let me just, so let's go back to what all we've done. So we're talking about degree of freedom. We think there were 15 variables, 10 were given directly. Now I start looking for clues. When I start looking for clues, I look for these kind of clues. When I look for these kind of clues, and I say I get 5 clues like these, then I know if I get 5 such clues, 5 such conditions or clues, then my degree of freedom becomes 0. I will be able to finally resolve all the variables algebraically. But that's not the case how it happens. What happens now is, usually in a tougher question, you would be given these clues. Suppose you're given 3 algebraic clues now, which are called non-direct algebraic clues. So I call them non-direct. So let's call them non-direct. The other were directs, so these are non-direct definitives. By definitives I mean equality-based algebraic clues. Yeah, these are equality based. Sometimes you will not be given these to you. Yeah, you will be given some clues which will lead to branching. Now, what do I mean by branching? Means they would give rise to conditions in which you would have to maybe use those conditions together either with these algebraic clues, right, or with amongst themselves to zero down onto the value of a variable. So, what kind of clues leads to branching? Inequalities. Yeah, when I say V1 is less than V2, one equality, V1 is less than 5, an inequality, right? V1 not equal to, again inequality, not equal to 4, that's another inequality, right? So, or they could be conditionals. Now, what are conditionals? What are conditional clues? Conditional clues arise because of lot of things. Let's look at some scenario. I say V1 is an even number. So I'm restricting the value of V1 to even numbers, right? So when I start solving and I start solving for V1, V2, V3 and everything, I say I get some degree of freedom, and because of some constraints, I get the value as possible for V1 as, let's say, 1, 2 and 3, and then I get a condition V1 is an even number. Now I know that V1 is definitely 2. Okay, so this could be one thing. It could be prime number. It could be anything. This could be given in this form: multiple of 5, multiple of 10, or it could be also bounded by some piecewise function. So you're given a clue based on a derived value, which might result into multiple scenarios through a piecewise function. So let's say for example, I say if I travel 0 to 10 kilometers by an auto, I need to pay 15 rupees per kilometer. Okay, but if I travel, let's say, mm, 10 or more, yeah, I need to pay something like, let's say, 7.5 rupees a kilometer total. And then someone comes and says, I paid 150 kilometers, 150 rupees. How far did I travel? Now they will branch. It could be 20 at the price of 7.5 per kilometer, or it could be 15 for up to 10. So this is what the two possibilities would come out. So see, piecewise functions also lead to these kind of conditions I wanted to talk about. Similar conditions and of inequality can come through ranks and orders, through transformative functions that we were talking about. So basically these are all transformative functions that we talked about, and how the transformation is taking place. Now, and you may have conditions that may come from uh, the fact that yeah, okay, so some more it's just slipped my mind. So there was something on my mind which I just wanted to highlight, but I could not. It just, yeah, so it could come out from various reasons which might put those conditions into saying that these are the possible values. I'm sure when we start solving some questions, I would be able to pick those conditions and tell you more about them. So these are some of the ways that you get those conditions. So you can also have if then else kind of conditions. So they might also play a role out here, that if this is this, then this is, if A and B are working together, then C should be working with D or something like that. So those kind of conditions also. Now, when you talk about these conditionals, the ones that I've talked about would be mentioned. These are the ones which should be explicitly mentioned in the question. So you would need to figure that out and do this. Okay, so when you talk about them explicitly mentioned in the condition, you say, okay, so this was written, that is there, right? Now what happens is there are some more conditionals. So let's go ahead to look at some more conditionals. These are implicit conditions or the implied ones. These are the easiest to miss. These are the ones that we sometimes don't realize. Now, what are these implied ones? Let's look at it. Let's look at a scenario. Let's say I'm talking about a football tournament. Okay. And we're talking about 5 teams playing matches against each other. So we have 5 teams playing matches against each other. We keep a record of the teams being A, B, C, D, and E. We keep a record. And the record is, we keep a record of saying that goals scored by A, goals for, and goals against. So you keep a record of these numbers. Yeah. So in that tournament, A played B, B played C, or whatever. So how many goals did A score in total, and how many goals are scored against A in total? Now, what would be the implied condition in this case? The implied condition in this case would be, it is not mentioned that the total of goals scored, this total of 4 goals, should be equal to total for against goals. Because if someone is scoring for one's own team, then he is scoring against another team. So this is something that is implied. It will not be mentioned in the question, and this is what you need to deduce. So this is the implied condition. Other than this, what are other? It's the simplest implied conditions, especially in questions of set theory, population, boys and girls, is that of cardinality. What do we mean by cardinality? By cardinality is the number of elements. If I talk about a population, so let's look at this, how it comes into play. That the number of people in a city, and we to start talking about, or in a class, number of girls in a class, number of boys in a class, can never be negative, and they cannot be fractional. So this is also there. That's a part of the cardinality. That's the part of the condition that is there, and it may not be mentioned explicitly. So if you're given something like this, let's say in a class, in a school, let's say 40% of students were girls. So this tells us that the number of students in the school have to be a multiple of 5, because 40 is 2 out of 5. So number of students per school should be a multiple of 5, number of girls should be a multiple of 2, and if we consider that the other gender is only boys, the number of boys should be a multiple of 3. So this should be 2k, 3k and 5k. So this is what is hidden, and this might help you solve questions later. Right. So there are scenarios when the conditions which are implicit might come into play. Now these conditions of cardinality, goals for and goals against, the ones that are picked up are called universal implied conditions. By universal this is commonsensical. We will derive it from here. Another example could be, let us say we are talking about a situation in which we're talking about the world, a scenario in which there is trade taking place between 5 countries. When you send, when one country sends it to another country, it's called export. When he gets from the other person, it's called import. Then if you're talking about just the trade between those 5 countries, then the total import should be equal to total export. That's another reversible scenario which is there. Right? So these are all universals, which means these are commonsensical. They do not. There are some more conditions which would be called the inferred conditions. Okay. Now, what are these inferred? They are specific to that question, and you would have to pick them up. For example, I tell you that my variable space, the variables are v1 plus v2 plus v3 or something like this. So I have these 5 variables, and I say v4 and v5, and I give you a condition like saying all the v's are multiples of 5, and I say this to you, right? I say all the v's are multiples of 5. Something, so every v is a multiple of 5, and I say this condition. I say, and these are the, let's say these are nothing but these variables are nothing but, let's say, volumes of of chemicals used for making a compound. Okay, so and all the others. And finally we say, and I say the total compound formed is greater than 100 but less than 110. So this is what I've said. The minute I tell you this and I tell you this, the inferred meaning out here should be that the total should also be a multiple of 5, because each element is a multiple of 5. And between 100 and 101, this would be equal to, you know, that total value is 105. Right? So this makes sense. We can do this and we will get to know. So this is an inferred thing. For example, let me just pick up another small example of that MCQ question that I did. If I said that the person in that test A scored, so the +3 -1 scenario, and I say A scored a score of 15 from, and there were 20 questions in it, right? Then I can say that the number of questions attempted by A will be of the kind 5 plus 4k, where k can take values of 0, 1, 2 or 3. So this is inferred. This is directly inferred. Okay, so this is how it will happen, and these are the things. So going back to our original scenario, picking up, now we can maybe move forward. I've done 2 or 3 things till now. I've talked about conditions. I'm not talking, so there are other things that we talk about when you do DILR, like how to find the starting point, how to start, if you're stuck, what should be the next variable that you can resolve. But then that would require maybe a slightly intensive course. Maybe we can look into that later if you put in a request, or we look into all of these scenarios in a course later. So going back, we've done 2 things till now. How do we attempt a question? So to attempt a question, you first identify the variables that you need to use to solve this. You identify how many of them are known, how many of them do you need to figure out after you have done all the direct ones out. So once you put the direct data in, you say, oh, this was all known, nothing left. So then you know it's calculation and you need to figure that transformative function out. Otherwise, you need to figure out those variables that, okay, I will need to find these variables out. I need to find the clues. You look at the clues. The clues could be now non-direct definitives, which are algebraic equalities, or they could be conditionals, inferred, non-inferred, implicit, or explicit, which are directly given to you. Based on that, at that point, when you look at this, you say, I have 10 variables, 8 are resolved, I just need to resolve 2 more. You look at the clues, you say, oh, will you be able to resolve all of them? Is there sufficient data? If yes, then this question will be totally resolved. If you've identified those, you should be able in a position to take a call whether you're able to solve them or not. Most of the times, when you're not, sometimes you'll not be able to identify these 10 variables itself. That will be a challenge. So in such a scenario, move on to a next question where you are able to identify the variables. When you identify the variables, one thing that I skipped and did not talk about, which I'd just like to highlight here is, once you understand, you need to know how do you want to represent those variables so that you are clear in your mind space. So a computer program might want to do them in a different way, but as a human person, I've worked with a lot of AI stuff and everything to represent that data. for the computer scenario. So, but for a human person, this would be this representation would be in form of a table or a chart. So, how do you want to do this? You want to make a grid? You can make a grid, a 2 by 2 grid. You want to make multiple grid, or you want to give one grid, and then you start representing and do that. So with this kind of a background there, I think we are now in a position to start solving another question. So maybe if you could pause it for some time and then we can